Next up, I have one of my lovely colleagues, Jack. Just to give you a little bit of an intro, I know Jack's going to tell you a little bit more about himself, but I'm going to give him a little intro because I think that's only fair. Jack has been at Handshake for nearly 6 years and was Handshake's first ever data scientist, and he now manages data science and relevance work at Handshake. Prior to joining Handshake, Jack completed his PhD, and I'm going to struggle to do this, but elementary particle physics, and completed the majority of his research at the Large Hadron Collider at CERN, which is pretty cool. If you ever get time to chat to him about that, that's an interesting discussion. But given this is the Employability Lab, we thought, why not invite a physicist and a data scientist to the lab as well? So perhaps he can bust a few myths about data science and also talk to us a little bit about how technology like Handshake uses data science to support students in their career search. I'd never met a data scientist before until I met Jack, who's really fascinating to talk to. I'm sure you will enjoy hearing from him as well. His session is titled All You've Ever Wanted to Know About Data Science and Machine Learning, which does seem like a tall order in 30 minutes, but I'm very confident that, Jack, you can make an excellent start. So over to you, Jack. Tell us everything we've ever wanted to know.
Okay, thank you, Claire. I'll do my best. So I maybe all those things that Claire said, I'm still pretty bad at using Zoom, so a little patience maybe. I think this is more or less what I need to do. All right, so as Claire said, I will be talking to you a little bit about data science and machine learning in 2 parts. I'll speak sort of generally about it, what these terms mean to various people, where you might hear them, and what they actually mean to me, which might sound a little bit more cynical than what a lot of others are telling you, but maybe you'll appreciate that. And then sort of to bring these things to life a little bit better, I'll talk about my particular work at Handshake in the careers, early careers, early talent space, using these techniques. And hopefully we'll have a little bit of time for questions as well. So to start on what these very buzzy terms mean, I will jump into a few diagrams and cartoons that were made by other people. And in the second section, you will see diagrams that are made by me, and perhaps you will come to understand why I borrow other people's diagrams whenever I can. So to start, we have one on one of many Venn diagrams that you will see that attempt to explain what the field of data science is as an intersection of a whole bunch of other fields. You have sort of academic, just traditional the careers, or maybe the disciplines, professional disciplines that have earlier derived from those, like software development, business analytics, and even machine learning. And then it presents data science as kind of this new intersection of all of them. And that's fine. I think maybe that is true in some cases. I'd say that's true in the language of it all, not necessarily true in the sense that a data scientist or someone called a data scientist will know all of these things really well and be doing them all at the same time. Similarly, I think this diagram sort of shows a little bit about what people who are called data scientists, or a job you see that's called data scientist, what that person may do. So this shows a lot of a very idealized picture of the different work with data that someone does in one of these jobs, from collecting and cleaning it, analyzing, to the very much revered techniques around building various models to forecast and predict things, and deploy them to consumer apps. And here you see sort of other roles that are familiar: data engineer, data analyst, machine learning engineer, and you see data scientists sort of spanning that whole bridge. Again, I would not assume that someone who's a data scientist is really doing all those things, but rather that if you hear or you meet someone who calls himself data scientist, they could be doing any of them, perhaps even none of them. But the language has sort of exploded to cover many, many, many things. So I'm going to talk a little bit specifically about the machine learning piece of this, because I think that's quite interesting and really applies a lot to what we're doing at Handshake. And be a little bit cynical about this as well, because as someone who studied quite a bit of statistics myself, I recognize, and I think most people who come from my position do as well, that machine learning is basically statistics applied to fancy, flashy business problems that make it seem a lot more exciting and to be honest, quite profitable, lucrative for many companies than just talking about statistics. So we like to think of it sometimes as applied statistics dressed up as art. Artificial intelligence is a subset of machine learning that is even more sort of flashy and buzzed about. But again, they're not sort of brand new novel concepts. They're just applications of statistics that we and that many students have studied for a long time now being applied to various problems in private industry, in government, and of course in cutting edge academic research. So what is this specifically? Here's a diagram that tries to explain, and I'll maybe walk you through this with a little bit more specific examples that you might relate to, where what machine learning is and what building a machine learning model is compared to the way we traditionally write programs. So in traditional deterministic programming, you will write a program in which you take some data and you tell the computer, here's what you need to do to the data to get an answer. So let's talk about one of the classic sort of machine learning products that I think many people have seen in some form or whatever, which is about real estate specifically. So many applications, sites that have listings of homes or flats for sale or for rent will, or even not for sale or for rent, maybe even take your home and try to estimate how much they think you should sell it for, or how much they think you should pay for somebody else's home. And so the inputs could be things like, where is it located? What is the typical selling price per square feet in that area, in that neighborhood, in that part of the country, and how large is the flat specifically. And then the program, of course, could be take the area, multiply it by the typical price per square foot in that area, and that will tell you, give you a good estimate output of how much it would sell for. In the machine learning case, we kind of invert this problem a bit. We do not tell it that the way to estimate how much a flat will cost is to multiply the area by a typical cost per area in that area, in that location. Instead, we give it a whole bunch of examples of flats that have sold. We tell it what they've sold for, that is the output. And the inputs instead would be, okay, how large were the flats and where was each one located? And then the computer, essentially with these inputs and with various techniques that allow it to play around with different formulas, programs to try to understand the relationship between the input and output, would then learn maybe first how much the relationship between the location and the cost, and then of course how to go from that to taking a flat in a given location, a given size, and sort of reverse engineer that output by figuring out that relationship between the size and the area. This is a very contrived example. Why would you ever need to do that? You might ask, and the answer is, it makes more sense when you start to throw a lot more data at it, a lot more outputs, and a lot more complicated inputs, so that you can understand, you can teach a computer to figure out much more complicated relationships than just the size of the flat and how much it will sell for. So that's one thing. If that didn't quite connect for everyone, there's more, and there'll be a few opportunities here. So you'll hear about that, and here's sort of taking this problem. You'll hear about terms regression and classification. They're kind of the same thing. Regression is just more as it is in statistics class, about predicting some specific number on some spectrum, like what will exactly this house sell for. Whereas classification, you usually have a very finite set of options. Will it be affordable or expensive, like categories? There's also classification in probably all of your favorite email clients. When an email is sent to you, they try to make a quick decision. Is it a good email or is it spam? And based on that classification, they may hide it from you or put it somewhere else. Those are the two most common and sort of foundational problems in data science and machine learning, and everything else sort of builds from them, including what I'm really interested in, spend most of my time studying, which is recommendations and relevance. So recommendations are exactly what they sound like. And recommender systems are things that I'm sure all of you have experienced in one form or another. Streaming services, I think the foundation of these days is all about recommendations and content, of course, right? Taking all of a large volume of content, and for each user trying to put in front of them the things that the application thinks the user is most likely, the customer is most likely to want to watch. And so you can sort of see that here. Maybe this particular screenshot of iPlayer isn't super personalized, or maybe doesn't look personalized, but let's assume that this user has gone and viewed various things such that BBC is convinced that they'd be most likely to want to see the things in the top row next. Another like more recent example that I think is probably talked about a lot in the industry these days as sort of the gold standard of recommendations is TikTok, which has this feed, of course, that is designed to keep pushing the thing that is going to capture the user's attention again and again and again as they scroll. And this is an example I really want to highlight when talking specifically about this generation of students who, of course, I am told use TikTok quite a lot, not because we at Handshake are trying to, say, monopolize their attention the way that TikTok does, but because one of the core problems that we face is that, well, students are very distracted easily on their computers, on their phones by many things, including things engineered in many cases specifically to just hold on to their attention for long periods of time, like TikTok. So talk a little bit about how important it is for us to try to efficiently get our student users the content that they need and want to see before they get distracted and move on to something else, and therefore not spend the key time to take the steps towards finding a job, connecting with an employer or someone at their career center. So that brings us then to the second part, where I'll talk specifically about the core problems that we work on at Handshake around essentially recommending jobs to students, putting the most relevant jobs in front of students to help them towards finding jobs and internships and discovering career opportunities. So this is a diagram. This is the first of my original diagrams, and it's a very non-scientific plot that shows the spectrum of students that I think you all will relate to and agree with, I hope. That shows on the x-axis how confident they are in their career plans, on the y-axis how many students, roughly speaking, fall along that spectrum. And of course, the peak, the most common paradigm you'll see is students who have some sense. They're not complete blank slates in terms of what they're looking for, but they are open to discovering more. And that's what makes sort of trying to figure out what's in try to place them in jobs, careers, or help them get there so interesting. And this is true. If I could show you this in terms of hard data that we collect at Handshake, it would show the same distribution. So what exactly does data scientists do at Handshake? This is a cartoon version of myself and a bubble of text of things that you might find on my CV. And it's all just kind of there, as maybe any CV looks like to someone who just picks it up. In very glib terms, we try to take what we know about students and jobs and figure out how it's all related and how to make matches between students and jobs. So right now it looks a bit unstructured. On the next slide, I've sort of magically turned it into a progression of my career from studying as an undergraduate in physics to continuing on to get a PhD in that, and then to take some of the, let's say, industry applicable skills that I got in my PhD towards my career in industry and a startup like Handshake. And this looks very clean, has a nice progression. Although you will see, of course, things that sort of don't connect from one stage to the other, because it's, as you know, not everything about the student plays a role in types of jobs and careers that they go into. But I think you also will probably, some of you might roll your eyes at this and say, it's never that clean. And I agree. It's not even that clean for me. It's just a nice diagram to show how this might work. And so, yeah, I use the information that we have, much of which is actually not shown or given an example on this slide, to recommend relevant opportunities to students, and also to help them naturally browse and discover more efficiently. So here comes the very suspenseful part of this talk for me, which is when we're going to try to do a poll. And so I believe you all can scan this QR code or go to slido.com and put in this number, and you can respond to this poll. So the question that I have for you is, if a student were to come to you for career advice or job recommendations, and you wanted to fairly quickly figure out the inputs, let's say, from them that you would need to direct them somewhere, what would you ask them first? Let's say you can only ask one question. And here we go, 3 options, and oh, I'm so relieved to see that this is working. There are no wrong answers. All right, you can keep going here, but I do think I'm going to move on. So we have, so far it looks like the most popular answer is, what is your course of study? Not too surprised to see that from this audience, and that is a fine answer. I'm going to talk specifically, though, about what is most interesting to someone like me who works has the privilege of working at a place like Handshake, which is actually the third option on this slide, which is what jobs have you looked at so far? And this is the one probably that is the hardest for any individual human to ask and infer something useful from, because that could be a very, very messy answer. And indeed it is. But at Handshake, we have some tools to make that work for us a little bit better. So let me walk you through a very contrived example of how we could take a large data set, right, of jobs, an anonymized data set of jobs that students are looking at, applying to, etc. And from that, build an inference about what they're interested in, and therefore what other jobs they should look at. And so this is my very simplified intro into building what we call a behavioral recommendation model. That is a system of recommending jobs based solely on the jobs that a student is looking at and other students looking at, as opposed to all of those things that you might expect to see on a CV. So, and this has been translated with the help of Claire for the British audience, with some hopefully some very recognizable brands. So let's say this is a student. It's also a friend of mine. Her name's Clara, and she is looking for a software engineering job. She views some jobs on Handshake, at Marks and Spencer, at the BBC, and at John Lewis. Let's introduce another Handshake student to this picture, Spencer. And he comes in, and we see that he saves the job at the BBC. Then let's bring in a third one, Jordan. She applies to the same jobs at Marks and Spencer and John Lewis, as well as one at a Scottish retailer called Shoe, I believe. I was in Glasgow a month or so ago, and my shoelaces broke, and they sold me some new ones, so they get a little bit of free publicity here. But I want to focus on them because they are a little bit maybe the oddball, the least recognizable name here. And let's just say hypothetically that Jordan is Scottish. Maybe she even goes to school in Scotland, and that's why she's aware of this opportunity, and she applies to them in addition to the big brand names. Based on this sort of graph that we've drawn so far, I think most of us would be comfortable making the assumption that Jordan and Clara have similar tastes. They've both essentially applied to a bunch of software engineering jobs at retailers. Therefore, it's reasonable to assume that if Jordan applied to a job at Shoe, found that interesting, appealing, appropriate, then Clara might as well. So we would recommend that same job to her. Now that's great, but I do want to like emphasize one point here, which is that we've been a little bit glib in talking about all these things, talking specifically about, are these retail brands, are these students, what types of jobs they're looking at. In reality, most of the time, none of that really goes into what we're doing. In fact, the data that we work with is in many ways quite anonymized on both the student and the job side. And mathematically, it works out that you could just take a set of students and jobs that look like this, right? The students are just indices, A, B, C. The jobs are indices as well. And essentially, you can put them all together into, let's say, a table of numbers that shows who's connected to who. You can, in math speak, factorize it. And from that, figure out which students are similar, which jobs are similar, and therefore which jobs would be appealing. And with a big enough data set, you sort of have to take my word for it here, but this can be so much more powerful on a large scale than trying to say, really come up with clever rules that say go from this is a student studying computer science to this is the right job for them. And so that's the power, I think, of large data sets that applications like Handshake are able to collect, anonymized sets of logs of who's applying to where. And they work incredibly well, even when folks like myself don't necessarily see or know a ton about the students, the jobs, et cetera, in any particular area. Yeah, so that about wraps up this demo, let's say. I do want to recap this. So of course, these recommender systems that are based on behavioral data are very powerful. They end up being incredibly personalized because they really kind of tap into specific jobs and things that or products that would be useful to a user. And the way we set it up right here that I think is really special is that there's not really much space for prejudice or assumptions, right? We have this diagram that shows the students, shows the brands, but none of the sort of core attributes of the student or the strength of the brand is in the code that we're writing. The only assumption that we're making is that one's past behavior is indicative of their future behavior, which on average is, of course, a quite reliable assumption in a system like this. And so we like to think of this as kind of a high-powered, very large-scale version of peer-to-peer learning. As students use our application across the US and the UK, our systems learn about them and about jobs, and therefore able to transfer knowledge about jobs to other students and help them discover opportunities. So going back to the poll, we have we had these different questions, different things you might ask a student to help them recommend them jobs. I would say when it is available, knowing the student's full history of browsing jobs and applying to jobs is of course the most valuable to us, but that's not always available, right? Some of you might have already thought of this example, but like, what if a student comes and uses Handshake for the first time and we've never seen what they've looked at? Of course, then that's not going to help you. So then some of these other questions become more important. And so there are no wrong answers here. Everybody's different. But the real benefit of having a large anonymized data set is that you can really dig in this incredibly rich granular level, and remove a lot of prejudice and assumptions from the jobs you're recommending to students. And the result of all that is sort of a page. This is a potential look for Handshake in the next year or so, of job recommendations presented to students, much the way that say various things you might want to buy are presented to you on your favorite retailer sites. And that is about all I have right now. So I will turn it back to Claire, who has been tracking questions.
Thanks very much, Jack. I really appreciate you taking the time to do this. I know this is very different to your day-to-day, and it's just one part of what you think about this kind of relevancy of job pieces across the whole of the network. So I really appreciate you taking the time to show us a little peek behind how data scientists think about some of this kind of work. So thank you for that.